Okay, so what you might not know is this is my third attempt at this video for this problem, but the dog keeps barking. So if I yell at her, I apologize. Now, when you guys are taking a look at question number 7, in question number 7, it gives you that there's 8,600 bacteria to start with, and after 1 hour, the count is 10,000. And this question's asking us to write a function that represents the growth of this bacteria after T hours. Well, in order for us to do that, we always need to know what our rate is. So we're going to end up having to find that growth rate. So as we go to do this, we know we're starting off with 8,600 bacteria, and then we're not sure what our rate is yet, but after 1 hour, we know that it's going to be 10,000. So we're going to have to solve for R, and it's in our exponent, so that should be the big clue to you guys that you're probably going to need some logs for this problem. So when we go to do this problem, first thing we're going to have to do is we're going to divide by 8,600. So we end up with 50 over 43 equals E to the R. Well, in order for us to solve this, I can natural log both sides, switch it to log form, it's really the same thing. So when I go to take the natural log of both sides, the natural log of E to the R simply equals R. So now we know that our rate is actually the natural log of 50 over 43. Now, we can estimate the natural log of 50 divided by 43. So it looks like it's going to be 15.1%. But that 15.1% was rounded. And so this next part then asks us to find the number of bacteria after 2 hours. So when we actually go to find the number of bacteria after 2 hours, we're going to use the function that we're about to write, but I'm not going to be using this rounded value. I'm using the natural log of 50 over 43. So our function would have been n of t equals 8,600 times E raised to the natural log of 50 over 43 times t. Now, it asks us to find the number of bacteria after 2 hours. Well, yes, I expect you guys that you're going to end up having to use this. So when I get to this point and I have 8,600 times E to the natural log of 50 over 43 times t, and that time my time is 2, this is what we're looking at. Now, there is going to be a few things that you guys are going to possibly find helpful as we move forward. Now, if I do not want to continue to do calculations in my calculator with the natural log of 50 over 43, your calculator will store that number for you. So the first thing that you guys are going to need to do is the natural log of 50 divided by 43. And you can just hit enter. Now, then you guys will see right underneath your ln, there's this button that says STO with an arrow. Well, what that does is that allows you guys to store this. Now, I'm going to go ahead and I'm going to store it as R because it's my rate. So I'm going to do alpha and then my multiplication symbol. And so now, anytime I'm dealing with this problem, instead of typing in the natural log of 50 over 43, all I have to do is use R. So my problem really is 8,600 times E to the 2R. because I know R is the natural log of 50 over 43. So when I go to calculate this, 8,600 times E, oops, wrong one. And so after 2 hours, we know that it is 11,627, and it has not reached 28 yet, so I cannot, oh, that should be bacteria. Now, the last question then says that it wants us to know after how many hours will the population double. Now, we know we started off with 8,600, and we know now that our rate is this, but we're using R, but this time we're looking for T. And so if I'm looking for when it doubles, some of you guys might want to actually do the 8,600 times 2, which gives us 17,200. But what you guys will find when you guys are looking for when things are going to double, if our first step is to divide by the initial population, regardless of what that initial population is, you're always going to end up with a 1 here and a 2 here. So we end up with 2 equals E to the RT. So when I go ahead and I natural log both sides, remember I'm solving for T because R we know what it is. So I end up with the natural log of 2 equals RT. So now in my calculator, I can go ahead and I can do the natural log of 2 divided by alpha. So it says that it will take approximately 4.596 hours for the population to double. And I almost made it through it.